Broadcast is now starting. All attendees are in listen-only mode.
Hi, good morning, everyone, from Toronto, Canada. Let's get started. Today we're going to be talking about Widget Designer programming statements and how we're going to be bringing in general or generic programming to the Widget Designer to make the Widget Designer be a little bit smarter and do some more things that we'd like it to do. So to start off, we're going to be going over things like if and else statements. And what those are, what they do. We'll be talking about switch statements, and we'll be talking about loop statements. Just a few things to make the widget a bit more powerful and a bit more flexible for what we need it to do. So starting off with this if statements. What is it? We'll just briefly go over what this is. If you don't know what an if statement is, we're going to explain that. If you do, don't worry, we won't be going too deep into this. So an if statement it takes a condition from outside and compares it to whatever you need to compare it to. So we'll go into that. So let's say it's basically a true or false statement. So we're going to look at something, see if it's true. We're going to do something with that. So in this case, if it's true, we're going to do an action. If it's false, we'll do a different action if we want. And then we're going to carry on beyond that. So I'll show you an example in the widget itself. So here we have the widget designer. So as a lot of you know, we have the node system. So we're going to be going through the node system very briefly, and then we'll be going into scripting in the widget designer. So here we have our we have a fader. We have our fader input node. We have our if statement basically as a node. So we're going to be comparing our fader value to a value that we've entered, and in this case, it's just going to be 0. So if the fader value equals 0, you can see here we have our what we want it to do, equals 0. Then, if it's true, do this action. If it's false, do this action. And then we go on from the if statement to the label output. So we can see that we're looking at the output value of the if node to change the label from off to on. So if this is not 0, you can see this is not true anymore. We're on the false part of the statement. So it's going to change this label to on. So the operator, that's what we're going to look at now. So if we go back to we're going to go back to this presentation here. So our operators, what can we do with in an if statement? We can see if our value equals something else. So this is useful for, we can use this for pretty much anything. We can use it for doubles, for numbers with digits. We can use it for just for regular numbers. We can use this for strings as well. So you can match one text with another piece of text. We can also use does not equal. So again, if a number doesn't equal a text, if a string doesn't equal another string, and then we have some that are only for integers or doubles, where we can test to see if something is greater than a number or less than a number. And inside of that, we can also say, does it equal the number or is it less than? Does it equal the number or is it greater than? And then using these operators, we can see if something is true or false. So coming back to the widget designer, we can see, so again, this is the node statement. This is the the node, and we can also use this for scripting in the widget designer. So I'll open the properties of this label, and we can see what we have for the if statement in here. So we're looking at the fader value here. That's the fader value. And we're saying if it's, resize this. If the fader is 0, then it's true. And we'll set this label to off. So we'll fade this down. And because this is a button, so it only activates when you click the button. And we're doing this so you can actually follow along with the free version of Widget Designer like this. There are some things, some nodes that we're going to be using where you won't be able to follow along, but I think about 90% of this, if you wanted to follow along, you could do this in the free version. So right now, we're going to push the button, and it's going to take the value of the fader. It's going to use this operator to compare it to this value, which is 0. So if the value of the fader is 0, then it's true, and it's going to set the label to off. If it's anything but 0, so it could even be 1, we'll push the button again, and it says, okay, well, it's this if statement is false, so it's going to use the else and the on here. And we can go a little bit further, and we have other things called, so we have else and else if. So we can actually use in the same thread. This is a little bit more complicated, but it's actually not too hard to follow, I promise. So because we have an action node here, I'm watching the value of the fader, as you can see at the top. So every time the fader value changes, you can see that this action script highlights itself, and it runs the script that's inside of this inside of the action node. So if I run this action node, move it over here, sorry, and we can see that it's activating, and it's saying it's doing our comparisons for us. So it runs this one first. If the fader value equals 0, then do this one. Okay, this is the first statement. So the first statement is true because it's at 0. We're going to go up a little bit, and it's saying all statements are false. We'll get to that in a second. Now we'll go up a little bit more. Now the value of the fader, we'll bring this up here. We can see the value of the fader on this side, so we know it's 114. The value of the fader is in between, so in between 100 and 150. And so now the second statement is true. Now we can go up to the very top, and we see that the value of the fader is 255, so the third statement is true. Now, the last part here is the catch-all. So if all the statements are false, then this catches everything else. And this is optional. If you don't want to have this, we can get rid of this else at the very bottom, and it won't do anything if these aren't true. So now we can say, okay, the fader value is 255, so that we can see the third statement is true. We fade this down. All the statements are false because we're outside of all of these parameters, all these comparators here. Then we'll go to the center. Okay, the second statement is true. We'll come back to the bottom, and again, we're outside of these parts here. So how does this line work? That's the next thing. So this is called a logical operator. So we've already talked about a comparison operator. So the comparison operator is equals, does not equal, greater than, less than, equal to, greater than, equal to, less than. So we can go to our logical operators where we can use and ors. So if we have a statement that we can have an if statement, and we can use an and after the if statement. So we can compare something. We'll say if the fader is greater than 100 and it's less than 150 in the case of this script that I've written, then it's true. But both of those statements have to be true for that if statement to be true. And then we also have another logical operator that's OR. So if the fader is greater than 100 or less than 50, we could have that statement true as well. And we'll go through how we would do that. So the AND statement, or the AND operator, we can see here. So right now, the fader's value is of 121, as we can see in here. The fader is both greater than 100 and it's less than 150. So we can see the AND here. So this statement is true because both of these are true. And another way we can see this, if we go to here, so here's our AND script. So I have another watch script here, or sorry, action node, and we can see I'm looking at both of these faders. So if either one changes, then it activates this action script. And I have my if statement here. So it's looking at the value of fader 1 and the value of fader 2. So if both of them equal 0, then this is true. So, and it's going to change this label here. So neither of them are 0. So we're at false right now. Now we'll put this one to 0. It's still showing false because we have the AND operator here. And then if I change this to 0 as well, okay, well now both are true. So we have fader 1 and fader 2 are true. So we go to the true, we can actually change this to true, false. So now both of the statements are true. So we can change this to true. Now, if we go to, if we change this to OR, so simply it's the exact same action node. I'll just change the wording here. It's the same action node, so we're going to change this to here. So one of them is at 0. So if fader 1 or fader 2 is at 0, then we're true. If one of them is, if neither of them are, then of course it's false. But if fader 1 or fader 2 is at 0, then it's true. Now you can add really as many as you want. You could add 100 faders in here if you wanted to. It might not be the best, the most efficient way to program, but we can continue adding fader 1, fader 2, fader 3, fader 4, and so on to say if any of them are at 0, then it's true. So if you had 20 faders and you used OR as the logical operator in this, then only one of them has to be 0 for that to be true. And where we could use this in programming inside of the widget. So when we use the let's say traditional way to program, the way we've kind of all learned, we know that the buttons have a toggle. So we can either click it or we can toggle the button, right? So in kind of the not traditional, in one way of programming, we can toggle a button. So if we click fade, we're going to run the onPress script, which will make the label or the fader fade up, and we're going to change the label of the text of this label to on. And then if we release the button, so we're going to click it again and unselect or detoggle it, I guess, it's going to fade the fader back down. And this is great. But what happens if we have manually brought the fader down, or another button has brought the fader down? Now if we click this button again, nothing happens because we're telling the fader to come back down. Or if we're almost full and now we want the fader to come off, if we click the button, well, now it's going to take 2 seconds to get all the way to the very top. Even if we're all the way down here, we're almost off, I'll click the off button, and it's going to take 2 seconds to get all the way to the bottom, which is, especially near the bottom of something, that can be a very long fade. So what we can use instead is an if statement to do the same fade. So in this button, what we have here is a kind of a different approach to the same thing, which is probably the dangerous part about programming. You can do everything 100 ways. So right now we're going to compare the same fader. I'll get rid of the other faders just so it's a little less happening on the screen. So we're looking at the same fader, so fader 1. If fader 1 is at 0, well, the fade it up. There it is. If fader 1 is not at 0, so if it's anything but 0, even if it's just 0.01, then it'll fade it down. So now we're going to fade it back down. But what I've done in here is I've actually done some inline math. This is probably something we'll cover more deeply in another webinar, but I'll briefly go over it here. So this fader's value is from 0 to 255. I want a 2-second fade. So I want it to fade from full to 0 in 2 seconds. From 0 to full in 2 seconds as well. So we have a nice fade, as we can see here. But as we remember, if we go like this, let's say we're at 50% and we want to fade it off, well, it takes 2 seconds to go from 50 to 0. So if I want the same speed from, this is 2 seconds. If I click fade off now, it's 2 seconds, 1 second, of course, half a second, and so on. Now I can bring this to 50%. And I'm going to take the value of this fader and I'll divide it by 128, because 255 divided by 128, or 256 divided by 128 is 2. So now this is 128, the value of the fader, divided by 128. Now it's going to take 1 second to fade this off, which is the same speed as fading it off from the very top. So again, we'll go into that more probably in another webinar, but I had it here and I thought I'd explain it. So this is one place where if statements is very handy, where if we want the fader to come off now, again, if we have it on a toggle, now the fader is going to go up to the very top, and now it'll turn off. But if you're using an if statement, no matter what, that'll turn off if it's not already off, and it'll turn on if it's off. So we can program kind of a more dynamic widget this way, where we can control things with more than just a toggle button. If something else is going to be controlling that fader, especially if we have external clients connected on a web browser and we're not sure if they're going to be controlling something that we don't know of, we can use this to make sure that our toggles actually toggle in the right direction no matter where they are. And of course, you can have this the opposite way. If it's full, you can have it turn off. If it's any other values, so we can program several comparators in here, different operators to make that work. Any questions on if statements?
Not so far. You explained every extremely thoroughly. Thank you.
Oh, okay. So we're going to go back to this. So next we have a switch. So a switch is kind of a more efficient way or a more direct way for an if statement. So instead of using many if statements all in a row, which can often be very hard to manage and organize, what we can do is use a switch. So a switch, we'll take our, you can see the circle up here. we'll take our regular running script, we'll run into a switch, and we'll give the switch a variable. So it's the same kind of thing as a fader, using the fader as the value to compare things to. And we'll come into the first case. So we use cases for a switch, and we'll compare what our variable is with everything inside of that case. So if it's true, if that comparator is true, we'll do an action. If it's false, well, then we'll actually go into another case, another comparison, and we'll see, okay, is this one true? The first one's false, so is the second one true? If it's true, of course, we'll do an action. I bet you'll never guess what happens next. Of course, we can keep going into as many cases as we want. It doesn't have to be numbers. It can be numbers or strings. And then we have an optional catch-all as well. If you want, we can use an else at the very bottom of this switch variable. So if everything ends up being false, we can say, okay, if everything's false, then do this action at the very end. Or you can also leave this else out. So if all the cases are false, then don't do anything at all if you want. And then after all these execute, the nice thing about switches, and I'll show you an example of this, is as soon as we're done with the switch, it exits the script. So if the first case is true, it doesn't bother comparing the rest of them. And this is important if you have very, very large, very large comparisons. If you have a large widget, then you don't want it to be calculating and doing all the processing of the rest of your variables. So at the end, when you get to the end of each one of these, you exit out of this part of the script and you continue executing the rest of that script that you have. So we'll switch back to the widget. So why you'd want to use a switch in place of if statements. So I've got an example here where our button here is going to be looking at the value of this label that's over top of it. And we're going to say, if this label says hello world, well then change the label to goodbye world, right? And I've put this in here so so we can actually see something happening. So a WD wait is kind of the same as sleep. We'll just put a pause into our script. So we're going to push this, and of course this statement is true. So it's going to change it into goodbye world. So then our second if statement, I've told it if it equals anything but hello world. So if this one, if the label says really anything but hello world, well then I want it to say hello world. So because our first statement changes it from hello world to goodbye world, that makes it true. And it also makes this statement true as well. So it actually changes it back. So we can, so it actually cancels itself out as it runs. So we see the first line, and then after it cancels it out, then it continues on. So it goes into this condition, checks this condition, executes that script. It carries on to the next script, which is a wait. And then it does this one. Whether this is true or false, it goes through that. And then again, it goes to the next line, and then the next line again, and so on. So we can see it changing to magenta here on the first line. It does this, changes it to hello world, goodbye world, sees that this statement is also true, and then it changes it to here. So if we were to change this from an if to an else, so if we change this else if, else if or if else? It's if else.
No, you have a bracket too much.
I do have bracket too much. There we go. So now we see it's it sees that this is our first if statement because this is true. it executes this, and then it chains these together because we have else if, and it doesn't execute the second one. Now, if I click this again, it will chain this together again and only do the second one. So we can do this, and we can keep adding else if all day. We can keep adding and adding and adding. Then we've got a lot of brackets, and we've got to organize things. So instead, we'll look at using a switch. So if we have something, we're using a drop-down menu in this case. So we do have, again, I'm looking at the drop-down menu here, and you see when I change this drop-down menu, it activates this by turning it. You can see it activating it by turning it blue. And then I have my if statement inside of this node. So the first thing that we do is we change the value of this so we change the text to welcome value, and that value is declared here with switch text demo. So we're taking the text from here, creating our own variable inside of this node, which is called value in this case, and then we pass it on to the rest of the script. So welcome, white space, plus, and then our variable for strings creates this text here. And then we change the color of it based on which name is selected. So we're saying if it's Curtis, change it to red. If it's Billy, change it to kind of an orange color. Oops, Billy. So we have a lot of if statements, but again, it will, and as when we're going for efficiency, this also comes into play. So no matter what, with if statements like this, it's going to compare the first one, and then the second one, and then the third one, and so on. Even if the first one is true, it'll always compare every single one of them in order. So then if your last one, if it conflicts with the first one, it'll still run the last one. So again, if you have this change the color of something and you're checking to see if the color is this, then they can step on each other. So I have the same type of thing here. It's the same script, but done differently. So again, we're looking at the drop-down menu, switch demo. And in this case, we have a switch instead of if statements. So again, we're looking at the value that we've declared in the top of this node. And I'm saying, in the case that it's Curtis, turn it red. In the case that it's Billy, turn it orange, and so on. Now, I also have at the very bottom here the catch-all. So if we have a name in here that doesn't exist, so let's say Johnny, we don't have a Johnny. We want the text to turn white and also set the name. So this is the catch-all, and if we get rid of this one actually, so Control X and apply. So we have Curtis, we have Ashley, that works. But if we go to Selena, nothing happens because I've gotten rid of that else at the very bottom. Is this making sense? Are there any questions here?
Yes, indeed, there are a couple of questions about the switch statement. So the switch statement just replaces a nested if statement. Could you just explain the difference between a nested if statement and the switch statement? Because it does replace it to a certain point, but not everywhere.
Yes. So again, I don't know if you could say this. Maybe there's no right way to do anything. There's just different ways to do things. So if we have nested if statements, we can start getting very deep. And we've mentioned this before. The indents, those don't actually matter to widget. This is just for organization in this case. So if we're using nested if statements, so a nested if statement would be if the value equals Curtis, and then we can put another one in here saying if this label equals hello world. Is this kind of what
Yes, that's exactly what was asked. Thank you.
Okay. Then we can, well, we can have a, so now we can have, so this is a nested if statement. So if it's Curtis, if the value equals Curtis, then it will execute these scripts, and then it'll run another if statement here. So we can have an if statement inside of an if statement and inside of and so on, as many as you want, which is okay. You can run all of these comparisons, and it's not too taxing on the system, but of course, the more you have, the more it has to process. And so now I can go to Curtis, and we'll open our debug, of course. We'll open our debug logger, and I will run this again, and Curtis. So this is this line here, debug message. The text says hello world, and so it does. Does that answer that question? Nested.
Yes, it does.
Okay, nested if statements and switches are kind of different, but we did. You're right. We didn't go over nested if statements. You can, of course, also have inside of a case or switch. Sorry, you can also nest if statements in here as well. So if I copy and paste the same lines from here to, let's say it's Billy, we can go to, we'll open up our debugger, we'll clear it out, and we'll go down, we'll go up to Billy, and again, it's this if statement is running as well inside of this switch. The things to remember though, if this is only, this is a Boolean, so the case will only test if something is true or false. Greater than and less than does not work in the case of this. And I'm not sure, and also like does not equal doesn't work either. The does not equal would be your, the catch-all at the bottom where we would use else here. And and we can go here and, oh, I did it wrong. Didn't I?
Oh, I got another interesting question for you.
Okay.
So with a case, it will stop processing all the other cases if one is true. And for the other example you showed where you had all the different if cases, there everything is processed, no matter which one is true and which not.
Yes. Sorry?
The question was to explain the switch case slightly more, so to show that it's if one is true, then everything else is just discarded and you're not putting any processing power into that.
Understood. So if we go into we're in the switch again. So if I write another case Curtis, so we already have that at the top. So and then I'll go debug message bottom case, and I run this. So we go Curtis. Well, it's going to run this one, and then it's going to exit the switch. So if I go Billy and then I go back to Curtis, it doesn't run. it doesn't run this. Sorry, I got rid of this one. That action script is working here because I have it showed in the debug message because I have this one in here already. So we can go down to Johnny. Okay, it runs the Johnny. Doesn't run the Johnny one because we don't have a Johnny. So if I do Ashley, there's Ashley, and then if I run Billy, it says this. Oh, sorry, Curtis is the one. So I have Curtis at the top and Curtis at the bottom. So I'll go back to Curtis. It doesn't run the bottom case because it's run the first case already. This one's already true. It runs this one and then it exits the switch and goes on to the next afterwards. So I can do debug message and code after switch. And we'll run this, and it's going to run this whole switch, and then it's going to run any lines of code that you have afterwards. But if we go into the if statement, and yeah, I'll get rid of this if statement here because that's a little confusing every time that pops up. Now if I say if value equals Curtis, and I'll do a debug message again. Last if statement. I'll close that bracket as well. Now we can run this again, and we see in our debugger, Billy. Okay, oh, I should get rid of these ones because again that makes it a bit confusing. Okay, I'll clear this. And Jill, and now we'll go to Curtis. So in the case of the switch, it would run the first Curtis and then exit everything. When it's an if statement, it runs the first one, then the second one, doesn't equal that, it's false. That one's false, that one's false, that one's false, and this one's true. So even if the first one is true, it'll keep running every if statement after the fact as well, which again isn't necessarily a bad thing. Maybe you do want that to happen. It would be easier, obviously, to just put this, copy this, and paste it into here. If that works for your situation, then this would be first if statement. So we can go to Jill and we'll go back to Curtis. So we have the first and the last if statement here, all executing at the same time. Does that make sense?
Yes, that's perfect. Thank you.
Okay. Any other questions before we move on?
So far not. Thanks.
Okay. So finally, we have loops. This is probably one of the, as far as programming a lot of things in your widget designer, this is a very, very useful tool in the widget. So what a loop is, we have our, just like any other statement, any other scripting that we have our entry point into our loop. And in the widget designer, what we do for loops, which is different from other software, we won't get into that now, but with loops, what we do is we declare how many times we want a loop to run. So we can do anything from really literally one time to 1,000,000 times if we want. And what happens is we start the loop, we declare how many times we want the loop to run, as I just said, and then we run the code inside of that loop. Once that code has executed, the loop counter increases automatically. We don't actually need to put a line of code in to increase the counter. That's automatic. And then it runs a condition. Is the counter done? If you said 1 to 10, it's gonna do 1, obviously 2, and so on. And if it's not at 10 yet, then it's false. The loop counter is not done. And it's going to do the code inside the loop again and increase the counter again until it gets all the way up to 10, in which case the counter condition will be done. So it'll be true. And then the loop ends and then carries on with the rest of the scripting that's inside of that loop, or sorry, inside of that block of code. So I'll go back to the widget and we'll show some examples of this. So here's a very simple loop where we just count to 10. Sorry, yes, we were counting to 10. But in this case, and this is where our efficiency in the widget comes in. And this is very handy. So in this case, we just have, I'm telling label 19 to count up to 10 manually. And we want to wait in there, obviously, because if we don't, it'll execute in a microsecond and you won't see the count. It'll just go to 10 immediately. So I put in a wait or a sleep in there. And as such, now we have 19 lines of code just to count to 10. Instead, running this in a loop would be, okay, I have the label wrong. But running this in a loop is a lot more efficient, and we can count to 100 with, I'll change the label here, count to 100, with just 3 lines of script. So I'll click on the button itself, then we can see it'll count from 1 up to 100, because we're increasing the counter in the loop. And the counter itself, we can actually declare as a value or as a variable, and we can use that variable inside of the loop itself, which is where it becomes very useful. So does that make sense so far?
Yes, perfectly fine.
Okay. So we can, again, we can count to 100, we can count to 1,000,000, and if we want to change this count, we can just change that, and we don't have to change any other lines. And we can also change the timing of the entire script just by changing one line in your loop. Instead of having to go in, if I wanted this to count to 10 faster now, I'd have to go in, and because I declared a value here, like a literal, and I didn't use a variable, I'd have to change all of these individually. Or, okay, I want it to go to 100 now, I'd have to type it in all the way to 100. So in this case, you're changing very little to make that happen. So where that is useful on shows or on projects, you can do things like control widgets that way. So in this case, I am changing the fading a fader up, changing the color of a button, waiting, fading it back down, and then changing the color of a button again. I'm going to make this happen a little bit faster. So we'll go, so we can see this fades a bunch of times, and if we want that to happen 10 times now, same thing. This will just happen 10 times without having to change or add any additional code in here. So one place it's very useful, I have a few projects, one in particular where I have, we have about 700 projectors, really, in a big circle. It's a screen that's about a mile long. We'll get into that another day. And we had to turn on 600 projectors. Now, obviously, 600 lines to get that done is not very efficient. And it's to change the timings. In a lot of venues where we're working, if you were to turn every single projector on at the same time, if every single bulb were to arc at the same time, you're going to blow fuses, melt transformers, and I'm speaking from firsthand experience here, this will happen. So it's usually smart to put a wait in between your turning on of projectors. And again, we're getting into specific use cases. Of course, there are different things to consider now where we have laser projectors and LED projectors and so on. But we'll just assume that these are traditional arc style projectors. So we will click the projector on button, and I've just changed this into a text, but we would do TCP send, and then your command to the projector itself. And I'll change this just for the interest of time here. I'll change the wait time, and I have 100 projectors I want to turn on now. And it's going to send this command to all 100 projectors in 3 different lines of code, 4 different lines of code, and that's it. So this can make it very efficient when you're controlling external devices. And then if you want to control something inside the Widget Designer, again, like the fader, I'll hide these buttons. So what I'm doing now is actually triggering a macro. And inside of that macro, I am changing the color of all of these buttons. So let's look at what that macro is. So with our macros inside of the Widget Designer or functions, I can call the macro and I can send a value to it to be processed. So the macro doesn't just have to run on an island by itself. I can actually send information to the macro as well for the processing that's happening inside of the macro. So in this case, and we'll look at what this context is, and we'll probably be getting into dot notation in later webinars. I know it's been requested. So if I say debug message, then I say context dot, and we have all of our members for this this parameter. So I want to use widget name or widget ID, it doesn't matter. So in this case, we'll use widget name so we can see it. So we see our widget name is custom script 13. So if I open our debugger and I click on this one, we can see that this context widget name is this custom script 13. If I do change this to ID, so it's the same as what we're sending to the macro, I'll hit apply and we'll click that button again and we'll see that it's going to send 13 to that macro, because this is what we've done here. So, and this is also a very useful tool. I'm going to delete this line. There's two ways, or there's a few ways we can get into our macros. One way, as we all know, is we click on scripting, scripts, and then we're going to go to color buttons, my ID. So that's one way to open macro. One, I think, easier way to get to it, especially when you have 500 macros inside of folders. You click on your macro, you right click on your macro and go to definition. And that directly opens up your macro as well, or your function. So I'm going to zoom in here. And the parameter that I've passed to this macro, I've told the macro to expect it in this line here. So we're expecting my ID. So if I type in this macro again, color buttons, and in brackets, it's looking for parameters. So this is, in this case, my ID. If I separate this by commas and say hello, doesn't really matter, and then apply, I can type this bracket again. We see my ID and then we see hello. So we're looking for these different parameters to pass to this macro. We don't need that right now though, so I will delete the hello. So this will keep working. Now we know the IDs of these buttons in this case. So we'll do this simply, I guess you could call it. So we see that this button ID is 9 and this last one is 26. So it will run all of the macro or all of the colors, because we have 9 to 26 for our loop. Our ID here is I, so it's going to enter in, it's going to automatically put in the number, sorry, of the loop as its variable inside of the WD custom script tint. And then we're going to tint it back to white. We are also going to label, or change the label of each macro, or sorry, each button from the macro. And then once that's done, we're going to take that my ID that we passed from the button, and we'll color the button that we clicked to red and change the text on it as well. So it doesn't matter which one is clicked, because every time we click it, we're running this part of the script, which changes every single button in this loop back to the default color. And then after that's done, it changes the color of it to red. So if I say WD wait, and I put a wait timer in there, and I click this one, you can see it changes it to white, and then waits 1 second, and then does the rest of it. So, and we can also see this. We can add pretty timers and things in here. So I have the same numbers, 9 to 26, and then I'm going to turn them all magenta with this button, the Cascade button. So if I click Cascade, we can see it change each one of them to magenta. And then if I click on any of these, it changes them all back to white again. Is this part making sense? Any questions?
No, that's wonderful.
Okay. And so for today, that's pretty much everything. When we get to loops as well, it's important to know that the loop variable is a variable like any other. You can use this in your scripts. You can do math with it as well. So if I want to change this label to, so I'm changing label I, so custom script I, which in this case would be 9, 10, 11, and so on, and I want to change it to do some math in line, I can click this, and it will do the math for you in that button. Or we can also add strings to it. Button number white space is important, because if you don't have the white space inside of the quotation, it won't. It will put the last thing in your string and whatever's afterwards together without that white space. So we can see that it treated it just like any other variable in the widget designer. So it's very powerful. So if I wanted this to be, if I wanted this to start at 1 for the labels, I could go in here and obviously -8, click this button, and we see button 1, 2, 3, 4, 5. Even though the IDs are 9, and even though the loop is running 9 to 26, we did that math in line. So this is also a very quick way to label your buttons. If you've got 100 buttons and you want to change all the labels at the same time or all the colors at the same time, you can do that. In this case, all the buttons are in order. There are other ways to do this, which you can find in the manual. If your buttons aren't in order, you can create other variables that have the button IDs inside of the variable, and pull from that to do that. It's probably something for our variable webinar, so stay tuned for that. And I think that's everything for today. If there's, again, no further questions.
For the moment, there are no questions, but we're also going to stay another couple of minutes online. So if there's any question arising, just write us something.
Okay, perfect. Thanks everyone for tuning in, and yeah, we'll see you next time.